It is truly astonishing that we, as minuscule beings who have scarcely ventured beyond the fragile veil of our planet's atmosphere, can sketch out a detailed map of an entire galaxy so vast that light itself takes 100,000 years to traverse its length. Imagine yourself standing in the midst of a dense forest at night, surrounded by billions of trees obstructing your view, yet somehow managing to outline the precise shape of the entire woodland as if gazing down from above. This is the grand paradox that humanity grapples with every day. Our beloved Earth drifts within a minor branch known as the Orion Arm, positioned approximately 26,000 light-years from the Milky Way's center and about 24,000 light-years from its outer edge. This location places us in a challenging spot, akin to someone standing amid the bustling crowds of Times Square, attempting to describe the full layout of New York City without the aid of an airplane or satellite imagery. In theory, the only way to accurately discern what our galactic home looks like would be to launch a spacecraft straight upward, perpendicular to the galactic plane, travel far enough away, and then turn back to capture a photograph. However, the harsh realities of astrophysics render this impossible, even with the most advanced propulsion technology available today, assuming we could sustain the speed of Voyager 1. The farthest human-made object, we would need 450 million years for that craft to escape the Milky Way's gravitational pull and reach an observational vantage point. That is an inconceivable span of time, long enough for Earth's continents to drift apart and collide multiple times, or for our civilization to fade and rebirth hundreds of times before the first image could be transmitted back. But let us indulge our imagination and perform the impossible. If you could break free and gaze back from the inky void of intergalactic space, the sight unfolding before you would seize your heart with its sublime grandeur. You would behold a colossal spiral structure with 4 primary arms curving gracefully outward from a brilliantly glowing core. Like luminous silk ribbons unfurling against the eternal night, that central bulge is not a monotonous sphere but a radiant bar, teeming with ancient stars in hues of golden orange, burning fiercely and crowding together in a mesmerizing, deadly dance. In contrast, the outer spiral arms shimmer with the blue glow of youthful, scorching stars freshly born, interspersed with dark dust lanes where stellar nurseries quietly operate. Amid this majestic tableau, our sun appears as a faint, anonymous speck, tinier than a mote of dust adrift in an immense ocean. Recent observations, including those from the James Webb Space Telescope and updated models incorporating dark matter distributions, suggest that the Milky Way's structure is even more intricate, with subtle magnetic field reversals in arms like Sagittarius and vast sheets of dark matter embedding the galaxy, influencing the motions of nearby systems and hinting at hidden forces shaping its form. So, if we cannot ascend to look down, how do we know all this? The quest to unravel this mystery began in the late 18th century, when the brilliant English astronomer William Herschel embarked on what seemed like a mad and futile endeavor. He resolved to count the stars in the sky. Assisted by his devoted sister Caroline, Herschel divided the celestial dome into hundreds of small sectors, patiently using rudimentary telescopes to tally the number of stars in each, meticulously noting their positions and brightness. After thousands of sleepless nights enduring frost and wind, he discerned a fascinating pattern. The density of stars grew overwhelmingly thick toward the Milky Band arching across the night sky, what ancient Vietnamese observers called the Silver River, while thinning out dramatically away from it. From this painstaking manual data, Herschel drew a revolutionary conclusion: our solar system resides within a colossal stellar assembly shaped like a flattened disk, resembling 2 plates pressed together. Though his initial sketch erred in placing the Sun at the universe's center, it laid the foundational brick, a leap in comprehension that allowed humanity to envision its cosmic abode. Yet, our mortal eyes and those early optical telescopes faced an implacable foe: cosmic dust. Vast clouds of dust scattered across the galactic plane obscure our view, preventing us from peering through to the other side of the center. It was not until the 20th century, when scientists began listening to the universe through radio waves, that clarity emerged. Radio waves, with their longer wavelengths, pierce through the densest dust barriers that ordinary light cannot breach, By tracking the movements of neutral hydrogen gas clouds via the 21 cm spectral line, astronomers mapped the velocities of gas regions. They observed that stars and gas do not move chaotically but orbit in an orderly fashion around the core. Using the Doppler effect to calculate which parts are approaching us and which are receding. Modern enhancements, such as the 2026 radio color maps from the International Center for Radio Astronomy Research, reveal even finer details, exposing hidden star births, deaths, and vast structures with twice the resolution and sensitivity of prior surveys, painting a vibrant picture of the galaxy's dynamic inner workings. These disparate data fragments resemble pieces of an enormous jigsaw puzzle. Assembling them, scientists discerned the characteristic spiral structure, pinpointing arms like Perseus, Scutum Centaurus, Sagittarius, and Norma. Moreover, by studying the frantic orbits of stars in the core region, humanity confirmed the presence of an invisible behemoth lurking at the galaxy's heart, a supermassive black hole named Sagittarius A. With a mass 4 million times that of our Sun, it acts as a gravitational anchor, preventing the entire galaxy from disintegrating into nothingness. Recent discoveries from 2026, including evidence of past explosive outbursts from Sagittarius A** reflected in nearby molecular clouds and the detection of a millisecond pulsar nearby, underscore its volatile history, flaring dramatically as recently as a few hundred years ago, potentially shining 10,000 times brighter than today, a reminder of the black hole's capacity for sudden fury amid its current quiescence. An intriguing fact that might leave you both dismayed and awestruck is that all the glittering images of the Milky Way you've encountered on the internet or in textbooks are not genuine photographs. They are entirely computer-generated artworks, crafted from raw data. Artists and scientists collaborate, inputting billions of parameters about celestial positions, brightness, colors, and motions into the most powerful supercomputers to simulate the galaxy's visage. These are the closest portraits human intellect can render, grounded firmly in physics and mathematics. Theories on the Milky Way's formation add layers to this portrait, emerging from quantum fluctuations post-Big Bang. It likely formed via a bottom-up process, where smaller clumps of dark matter and gas merged hierarchically, influenced by gravity and dark matter halos, evolving from chaotic beginnings into the structured spiral we inhabit, with recent findings suggesting its last major merger occurred as late as 3 billion years ago, reshaping our understanding of its growth. Today, with the assistance of the GAIA satellite, a space observatory that tirelessly measured the positions and motions of nearly 2 billion stars with precision down to microarc seconds, the three-dimensional map of the Milky Way grows sharper than ever. We know its diameter spans about 100,000 to 120,000 light-years. Yet the surrounding dark matter halo extends far beyond. In this macroscopic scale, the existence or extinction of all humanity is akin to a fleeting blink, an inadvertent ink dot on the vast cosmic page. But this very insignificance elevates the grandeur of knowledge. Though confined to a tiny corner of the universe, our curiosity has winged our minds farther than any spacecraft, piercing through murky dust clouds to behold the portrait of our own home. Perhaps, in some distant future, our descendants will discover ways to warp space, step outside, and for the first time witness the Milky Way with their flesh and blood eyes. And when that sacred moment arrives, the universe may no longer seem a cold, alien expanse but a boundless playground awaiting Earth's children to return. Yet the tale of this grand home does not end with its serene form. The universe is a symphony of chaos and ferocity far beyond our imaginings. The Milky Way does not stand still, it spins at a dizzying pace. And its spiral arms, harboring billions of young, blazing stars, continuously generate density waves, sparking the birth of new stellar generations. If you could attune to the universe's sounds, not with ears but through gravitational waves and electromagnetic radiation, you would hear our galaxy singing. It is the rumbling of pulsars spinning hundreds of times per second, the crisp explosions of supernovae tearing through space, and the eerie whispers of stellar winds sweeping across colossal molecular clouds. Recent detections of large-scale vertical corrugations propagating outward in the galactic disk, like a great wave rippling through the stars, further illustrate this dynamic evolution, challenging prior models of stellar motions and hinting at unseen perturbations from satellite galaxies or dark matter interactions. Moreover, the Milky Way's destiny is intertwined with a fateful rendezvous ahead. Computer models predict that in about 4.5 billion years, though recent 2025 analyses incorporating influences from the Large Magellanic Cloud and Triangulum Galaxy suggest only a 50% chance within the next 10 billion years, our galaxy will collide head-on with the Andromeda Galaxy, our colossal neighbor hurtling toward us at 110 kilometers per second. Should it occur, Earth's night sky, if Earth endures, would transform into an unparalleled spectacle of splendor and terror. The two galaxies would entwine in a gravitational dance lasting billions of years, shredding their elegant spiral structures to forge a new elliptical giant, whimsically dubbed Milkomeda by scientists. This merger would not destroy stars outright, given the vast emptiness of space, but it would hurl systems into new orbits, potentially flinging our Sun to the galactic outskirts while igniting bursts of star formation amid the turmoil. Contemplating this, we realize our presence here and now is a probabilistic miracle. We are awakened stardust, the universe's way of perceiving itself. That we can sit here, with brains weighing scarcely more than 3 pounds, pondering a structure 100,000 light-years wide, is the most eloquent testament to consciousness's power. Though our bodies are bound by a small planet's gravity, our minds have truly journeyed through twisting arms, glided past vibrant nebulae, and brushed the edges of black holes. Perhaps we have never truly left home, but we have switched on the lights and explored every nook of this vast living room. And in knowledge's glow, the Milky Way ceases to be a mere indifferent band across the sky. It becomes a vibrant organism, a legacy of the past and a cradle for our future. Each time you lift your gaze to the star-filled night, remember you are not merely staring into emptiness, you are gazing at yourself, at the glittering bloodstream coursing through the veins of the boundless cosmos. We extend our deepest gratitude to the pioneers, the astronomers, physicists, engineers, and silent sky watchers across centuries, from William Herschel's frost-bitten nights counting stars to the intricate algorithms of today's data scientists, from the first lens grinders crafting telescopes to the teams operating cutting-edge space observatories. It is through your boundless patience and thirst for truth that humanity, a diminutive species, has transcended the limits of naked vision to behold the true beauty of our cosmic dwelling. Thank you for igniting the torch of knowledge amid the endless night.